Hey everybody, it's Mr. Stoltenberg again. Today we're going to be starting our next unit. It's unit 12 or 13, I can't remember what number. It's the reactivity unit. In this unit we're going to go over acid-base chemistry. We're going to learn about things called pH, pOH, and deal with that, the calculations that go along with that. And potentially more. We'll see how, we'll see what we can get to. But today it would just be a basic introduction to what qualifies something as being acidic or basic. So today's activity is just designed to introduce you to the concept. I understand when we get into this that you have, for the most part, no idea what qualifies as acidic and what qualifies as basic. So this is going to be a lot of guessing today, but hopefully by the end of this activity you'll have a little bit better understanding of it, and then we'll get into the notes and whatnot in the next video. Alright, so here's how the activity is going to work. Soon you'll be given a list of items, household items that for the most part you're familiar with. Some of them you may not be very familiar with, and your goal is to classify them as being either acidic or basic. What we'll do is create a T-chart, and I've provided a template that you could download, or you can just create one on a piece of notebook paper if you want. One side of that T-chart is going to be labeled acidic, the other side is basic. And so basically you're going to go through this list of items and kind of just decide whether or not you think it's acidic or basic. Like I said at the beginning, it's going to be pretty much blind guessing. Along the way, I'll give you 3 different clues that might help you organize your list a little bit better. If you need to make adjustments, make adjustments. After each clue, you'll have time to adjust your list. In the end, we'll stop and finalize it, and we'll see how close you got it to being right. Try not to cheat on this. And this is just for fun, and I'm not grading. I'm not going to be grading whether your answers are right or wrong. I'm just looking for participation, and it's kind of like a game, so just enjoy it for what it is. Alright, so hopefully you have your T-chart created, or you have the one that the template printed out. Let's get going. So here's your list. We have vinegar, soap, wine, aspirin, tonic water, black coffee, lemon juice, Tums, saliva, cigarettes, pure water, white bread, eggs, baking soda, and milk. Alright, so let's see, what is this? 15 different items here. Start placing them on your T-chart on either the acidic side or basic side. Again, you're kind of just guessing here, but you probably have a general idea what an acid is and capable of doing. So kind of use that to maybe help guide some of your decisions. I'm going to have you pause it now, work till you get most of this list filled out. If you don't do it all right now, that's okay. You're going to get some clues, but try to place most of it right now. I'd be using a pencil or something that you can easily erase or mark through on this first iteration of your list. So go ahead, pause the video, and then when you come back, we'll go get our first clue. Alright, first clue time. Here we go. Clue number 1, acids tend to have a sour taste and bases tend to taste bitter. Acids tend to have a sour taste and bases tend to taste bitter. This will be really helpful if you can distinguish between sour and bitter. So think about it, make some adjustments, think about what might taste sour, what might taste bitter. Those two tastes are kind of similar, so it might be hard, somewhat difficult to distinguish between them. Okay, go ahead and pause the video if you need to before we move on to clue 2. So pause now, make your adjustments. All right, moving on. Here comes clue number 2. Acids can be very corrosive to metal. Now this clue might not be super useful for some of these items, but think about it. If you took, whatever the item is and you put it on metal, would it do anything? Would it leave a mark? Would it start to corrode it over time? Think about it in those terms and it could be useful. Okay, again, make any adjustments that you need to do. Move things over. No rush here. Take as much time as you need. Go ahead and pause it now and we'll finish with clue 3 here in just a second. All right, last clue. Here we go. Bases can feel slippery. Bases can feel slippery. Like if you had a base on between your thumb and your pointer finger, and you were rubbing your fingers back and forth, it would feel very slippery. So think about some of those substances or items that you have on your list. Think about how they would feel on your skin. All right, this is the last clue, although it does say clue number 2 up there. I just realized this is the third clue and the last clue. So we're going to finalize our list. So pause the video, finalize your list, and we'll come back and we'll check it. So pause now. All right, hopefully your list is finalized. Again, I'm not checking to see if you're right or wrong. I want you to legitimately guess. So again, don't cheat. Give honest answers here. So are you ready? Are you ready? Okay, here we go. On the acidic side, we have vinegar, wine, lemon juice, white bread, milk, aspirin, and black coffee. On the basic side, we have saliva, eggs, cigarettes, soap, tonic water, Tums, and baking soda. So there you go. Oh wait, look at that. Pure water can be considered both basic and acidic, but most of the time it's considered neutral. We say it's neutral, but it actually can be considered as both a base and an acid. This is something that's called property that's called being amphoteric, but we'll talk more about that later. So there your finalized list. Vinegar, you probably should have known that is an acetic acid, and we've talked about it before. Wine, for those who don't know, does have a sour taste. Lemon juice, obviously, very sour. White bread can be, have a kind of a sour taste to it, and milk and aspirin. Also, if you've ever had bad milk, especially the expression sour milk is said that way for a reason. Black coffee is one that would have kind of tripped me up because I would have thought black coffee tastes bitter, but it is acidic. Think about what it does to teeth and how it can corrode and stain teeth. That has to do with its acidity. Then on the basic side, saliva. Saliva is very slick and slippery. That's not surprising. It's the same thing with eggs, right? Egg yolk and egg whites are extremely slick and slippery. Cigarettes. Honestly, on this, I pulled it off a list. I don't know how they're basic or like if they grinded it up and tested it, or I don't know. But cigarettes are considered basic. Soap was probably one that you got after the slippery clue. Most soaps, most cleaning supplies are considered basic. some cleaning supplies more than other. Tonic water is water that has had a chemical added to it. I can't remember the name of the chemical off the top of my head, but it changes its pH to where water, where it's pure water normally neutral, it actually makes it basic. Tums is the medicine, the anti-acid medicine. When you eat Tums or any other medicine that's supposed to help settle your stomach, what you're actually doing is neutralizing the acids in your stomach, and the way you neutralize an acid is with something that's basic. So Tums being basic makes a lot of sense. And then baking soda is very common base. Baking soda is often used to neutralize spills in like acid spills in laboratories. All right, so this is the pH scale. Whoa, that's really blurry. Sorry, hopefully you're not, this doesn't hurt your eye. We'll talk about the pH scale a lot more in the coming videos, but pH scale runs from 0 to 14. On the lower end are your most acidic things. Low number pH means you're acidic. On the higher end, it means you're basic. So a pH of 1 or 2, or 0 to 1 to 2 is a very acidic substance. Or a pH of 12, 13, or 14, very basic. Whether or not something's considered an acid or a base depends completely on the concentration of the chemicals that's within. Generally speaking, low pHs and high pHs are pretty dangerous chemicals, but anywhere within that middle of that range, generally speaking, we're dealing with relatively harmless stuff. So just because something's considered an acid, bananas, doesn't mean it's particularly dangerous. And just because something's considered a base doesn't mean it's not dangerous. Drain cleaner. We'll get into that a little bit later. But here's some general characteristics of acids and bases, and these things that we'll touch on as we move forward. Again, acids are pH less than 7. They tend to taste sour. Although you should never use this to identify an acid in a lab. Please don't ever taste anything in a lab. Will react with metal to form hydrogen gas. These reactions usually come along with some bit of flammage. The next 2 points are the basic. These are the textbook definitions, and we'll learn these next time. Increases the hydrogen concentration in water, or can also be said that it donates hydrogen ions. And then it turns blue litmus paper red. Litmus paper is just an old school acid pH indicator. Don't really use them that much anymore since they have digital pH indicators. And then bases, anything with a pH above 7 is considered a base. They tend to taste bitter, slippery taste, slippery feel, soaps and cleaners. Increases the hydroxide concentration in water and is known as the hydrogen acceptor instead of the hydrogen donor. And of course, it turns the red litmus paper blue. So what do you notice about these two definitions? Is they're kind of exact opposites, and that's kind of what acids and bases are in the chemical world. They're pretty much the exact opposite of each other. We'll talk a lot more about it moving forward. Hope you enjoyed this activity. Just kind of a fun way to introduce acids and bases, but we'll get into the notes in the next one. All right, see y'all.